We have another example on the board. Please notice that this time we have given voltage source RMS. And the problem is asking us to find the peak value of current which goes through the resistor and the RMS current which goes through the inductor. So what we're supposed to do first? No matter what voltage we have given, we're supposed to find Z total first. In order to find Z total first, I have to find the impedance of the inductor. In order to do so, I'm supposed to use the formula which says ZL is equal to 2 pi FL. So I have 2 pi times the frequency, which is equal 1000 over pi hertz, times L, 200 millihenries. Pi and pi will cancel out, so ZL is equal 400 ohms, and don't forget about angle of 90 degrees. ZL goes always with angle of 90 degrees. ZL or X of L, right, is the same thing. Next, I can find Z total. Z total is equal resistance plus ZL. Why? Because this is series circuit. Okay, and this is the formula for total impedance of the series circuit, RL series circuit. So if resistance is equal 230 ohms plus ZL 400 ohms and angle of 90 degrees. So Z total is equal 461.41 ohms and angle of 60.1 degrees. This is the total impedance of my circuit. Next, I can find I total. So I have I total is going to be equal to the current which goes through the resistor, and this is going to be also equal to the current which goes through the inductor. Why? Because this is series circuit. And of course this is going to be RMS current. Why? Because I'm going to divide voltage source, which is RMS, by Z total. So if you divide RMS voltage by impedance, your current is going to be also RMS. So I have voltage source 100 volts divided by 461.41 ohms and angle of 60.1 degrees. This is equal 216.72 milliamps and angle of negative 60.1 degree. Of course, RMS. So I can say that I found IL RMS because I total is equal to IL. The problem is asking me to find the current peak which goes through the resistor, okay? So you have to remember the formula which says that I RMS is equal I peak times 0.707, okay? Just change this to the capital R. In order to avoid the confusion. So in order to find peak current, I'm supposed to divide both sides of this formula by 0.7 0.07. So I'm going to have, in this case, I, which goes to the resistor, peak, equals IR RMS divided by 0.707. So my IR RMS is equal 216.72 milliamps and angle of negative 60.1 degrees over 0.707. This is equal 306.53 milliamps and angle of negative 60.1 degrees. This is the peak value of the current which goes through the resistor, and of course this is the peak value of the current which goes through the inductor, and this is also equal to the total current peak, okay, because this is series circuit. In series circuit, current is everywhere the same. So we found IL RMS, we found IR peak. Next we can find VR RMS. In order to find VR RMS, I'm going to use the Ohm's law. So VR RMS is equal IR RMS times resistance, where IR RMS, we said this is the RMS current because we divide voltage source RMS by Z total. So I have 216.72 milliamps and angle of negative 60.1 degrees times resistance, which is equal 230 ohms. This is equal 49.84 volts and angle of negative 60.1 degree. This is my voltage across resistor, RMS. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta. So I have cosine of angle which is next to Z, so I have 60.1 degree. This is equal 0.498 lag. Let me remind you, in some books you are going to see lag, in other book you are going to see lags, in another book you are going to see lagging, but this basically means that the current in the circuit, right, lags the voltage source. Okay, so this is the power factor. Next, we're supposed to find the true power. True power is equal voltage across resistor to the second power over resistance. Now, please notice that this time we are not going to use the formula, which is P equals 1/2 VR to the second power over resistance. Remember, this formula we are going to use for RMS values. This formula we are going to use for peak values. So if I have voltage R, right, expressed in terms of RMS value, right, so I'm going to use this formula. If I'm going to have voltage peak, I'm going to use this formula. The same happens when we have formula for power, where I'm going to use current. So I have I R square times R. So this is for RMS. Okay, let me just write this down. This is for RMS values, and we have power equals 1/2 IR square times R for peak values. What I mean for peak values, I mean that voltage across the resistor must be peak, or the current must be peak, okay? So when I'm going to use these formulas, I have to make sure that the voltage is going to be RMS and current is going to be RMS. So we have to find true power. P true is equal the IR square times the resistance, where IR, we found the RMS value 216.72 milliamps raised to the second power times the resistance, which is equal to 30 ohms. This is equal 10.8 watts. Someone is going to say, I want to verify if this is true. So let's try. P is equal 1/2 IR peak square times resistance. So I have 1/2. The peak current in the circuit was 306. Okay, we calculated. So I have 0.53 milliamps raised to the second power times 230 ohms is also equal 10.8 watts. Okay, so let me just tell you one more time. If you have RMS value of current, you're supposed to use this formula. If you have peak value of current, you're supposed to use this formula. Next, we're supposed to find QL, reactive power. QL is equal, I'm going to use RMS current. I have IL to the second power times ZL, which is equal to 216.72 milliamps raised to the second power times ZL, which is equal 400 ohms. This is equal 18.79 volt ampere reactive. This is my QL. If I want to find the apparent power S, this is going to be I total square times Z total, which is equal 216.72 milliamps to the second power times Z total, which is equal 461.41 ohms, and this is equal 21.67 volt amp. Okay, so this is my apparent power. If you want to draw the power triangle, simply draw. This is the true power, which is equal 10.8 watts. Next, I'm supposed to draw the reactive power QL. Remember, QL always goes up. So I have QL equals 18.79 volt ampere reactive, and I have my apparent power. Okay, let's make this a little bit longer. I have S equals 21.67 volt amp. So we found the currents, voltage, power factor and powers, so we can say that the problem is solved.